we're going to graph this tangent function. The first step in graphing a tangent function is to find the period. So your period is always related to your b right here, which is 1. It's the number in front of the x. So your period equals pi divided by b, which is just 1, so the period is just pi. So the first thing to do is to think about what a tangent graph looks like. And remember, a tangent graph is going to be like, here's your asymptotes at pi over 2 and negative pi over 2. Those are your asymptotes for a tangent graph. And your base graph looks something like this. And again, that's because the tangent, think about the tangent as the sine over the cosine. And wherever the cosine is 0, there's going to be an asymptote because you can't divide by 0. So where does the cosine equal 0? On a standard graph, it equals 0. Like, think of your unit circle. My unit circle, where's the cosine is your x-coordinate, right? Cosine sine. So the cosine, the cosine is 1 here, it's 0 here, and it's 0 there, because you're not going over left or right. I should say cosine x. These should all say x in them. I'm just being lazy. Okay, so this is pi over 2, or 90 degrees, and this is negative pi over 2, or negative 90 degrees, or 3 pi over 2, etc. So that's why you've got an asymptote at pi over 2. But when you shift it, so your first step is to find the period. So since my period is still pi, that's good. That means that I'm going to be centered, and it's going to be pi over 2 and negative pi over 2. But now I have to figure out what the shift is, the phase shift or the horizontal shift. The horizontal shift has to do with this number right here, and it's negative pi over 4. So all of these asymptotes here, I'm going to subtract pi over 4 from them. Subtract pi over 4. And you can even subtract pi over 4 from this, but I just wait and put that right in the center. Okay. So if I subtract pi over 4, that means I'm going to be at pi over 4, and I'm going to be at negative 3 pi over 4. Right? Because this is like negative 2/4, right? Yep. So I can, and then, well, let's do that. Let's take care of that first. So let me just make a little graph up here so you can see what it looks like. Here's my x-axis and my y-axis. I waited to draw it because sometimes I don't know how much it's going to shift. I don't know where I should draw my axes, but that's plenty. So there's my x, there's my y. Let's call this negative pi over 4. Let's call this positive pi over 4. So this is negative 2 pi, this is negative 3 pi over 4. Or no, sorry, negative pi over 2, negative 3 pi over 4. Right? My asymptotes are going to be at pi over 4. There's one asymptote. And 3 pi over 4. And my 0 is going to be right in the middle. But I'm not going to put that there yet because I have some other shifting to do. Right? So instead of putting that point there, I'm going to look back at my graph now and see, well, it shifts also up 1. So my graph, instead of being on the x-axis, it's going to be here. So there's that middle point, that handle point. And this 2 in front, that kind of affects the quote-unquote amplitude. It's not really an amplitude, I don't think, of a tangent. That's more of a sine-cosine term. But it still affects how fast you're going up. So typically, if you look back at my original graph down here, typically you would go over, you would go up 1, like your normal graph. Again, let's look at your normal, the green graph, the original graph, which is tangent of x. The graph of tangent of x will go at pi over 4, it's going to be 1. So that value is 1 right there. And at negative pi over 4, the value is negative 1. Right? Yeah. Because if you think of your unit circle, those values on your unit circle are pi over 2, comma pi over 2, and pi over 2, comma negative pi over 2. And the tangent at both of those points, your 45 degrees, your pi over 4s, which are 45 degrees, the tangent of both of those are 1 and negative 1. Okay. You understand? Okay. Sine divided by cosine. You follow? That's why that point is usually there. But if you have a 2 in front here, what that does is it doubles, instead of being 1, now it becomes 2. So it stretches the graph out. So So this 1 moved it up 1, and this 2, instead of going, let's make this, this is obviously 1, instead of going over, like the halfway point here is the y-axis. So instead of going over 1, up 1, to right here, I would go over 1 and up 2. So that point would be right there.
Right.
Well, let me change that to red. Okay, and same with here. Instead of going over 1, down 1, it's over 1, down 2. So it's there. And your graph, I'm going to run out of room, but your graph is going to look like this. That's what your graph will look like.
Okay.
All right, so that's how you graph a tangent. And then, of course, it's going to repeat. It's going to come over here and do the same thing over here. So this point's going to be here. This point will be here, and that point will be up there, and the same thing's going to happen over there.
Okay.
All right.